Welcome to the next video of the fifth section, deciding the data structure and creating the player class. In the previous video, we have learned about the program structure and Broadview skeleton. In this video, we'll learn how to decide the data structure and we'll learn to create the player class. Sticking to the model-first philosophy, let's spend some time on deciding the appropriate data structure or model for the program. The data structure of the audio player is fairly simple. All that we expect of the model is to keep a track of playlists. The main data then is a list called play_list, and the model class is then simply responsible for the addition and removal of items to and from the playlist. We accordingly came up with these model class for the program. Nothing fancy in this code. The object simply consists of a Python list with various utility methods that can be used to add and remove items from the list. The play_list method has been declared as a property, so that we need not write the getter method for the playlist. This is definitely more Pythonic because a statement such as play_list equals self.play_list is more readable than play_list equals self.get_play_list. Now, let's write the code for the player class. The class will be responsible for the handling of audio playback and its related functions such as pause, stop, seek, fast, forward, rewind, change of volume, mute, and so on. We will use the Pyglit library to handle these functions. Pyglit is a cross-platform library that uses the AV-bin module to support a large variety of audio files. You might want to look at the API documentation of the Pyglit player, which is available at this site. You can also access the documentation for the Pyglit media player class by typing these two lines in the Python interactive shell. The online documentation at this site tells us that we can play an audio file by using these code. Accordingly, the code for the player class is like this. This code is built on the Pyglit API, which is quite intuitive. We will not get into the details of audio programming here and trust the Pyglit library as a black box that delivers what it says, namely to be able to play and control audio. These are the important things that you should note about the preceding code. We define the play_media method, which is responsible for the playing of audio. All the other methods support other functions related to playback, such as pause, stop, rewind, forward, mute, and so on. Note that the code defines a new Pyglit player class every time it wants to play an audio file. Though we could have used the same player instance to play multiple audio files, it turns out that the Pyglit library does not have a stop method. The only way we can stop an audio file from playing is by killing the player object and creating a fresh player object for the next audio file playback. When it came to choosing an external implementation as we did for the audio API here, we first searched through the Python standard library at this site. Because the standard library does not have a suitable package for us, we turned our attention to the Python package index to check whether there exists another high-level audio interface implementation. The Python package index can be found here. Fortunately, we came across several audio packages. After comparing the packages against our needs and seeing how active their community was, we settled for Pyglit. The same program could have been implemented with several other packages, though this would have been done with varying levels of complexity. This concludes the iteration. We now have a functional player class that can manipulate audio files. We have a data structure that consists of a play_list with various methods to add and remove files from a playlist. We will next look at how to add and remove files from a playlist from the front end of the program.